Greetings, this is Mark Anderson from Kellogg Community College, and I am going to be doing some binomial expansion with you. And in the previous 3 videos in this series, I started off with looking at just general A plus B binomials expanded that had no other tricky coefficients. The Pascal's triangle was also introduced. In the second video, I talked about what factorial means and how combinations can be used when factorials can get really big, or the binomial expansion powers get really big. And in the third video, we actually got to the formula itself and how that was created. So in this video, we're just going to start writing out these expanded forms. We're going to start off with this problem, 4x plus 3y quantity cubed, and this is going to need 4 terms. As explained in the third video, you will always have one more term than the degree of your binomial that is to be expanded. So there's going to be 4 here. In the previous video too, we talked about starting off with the combination notation, and that starts with the 3, which is the highest power here. All of these actually are 3. And then we'll start here with 0 and increase that until it gets to the match here, which is 3. Then our 2 small little baby owls, again explained in the third video. These are going to be the 2 terms of the binomial. So this is 4x and this is 3y. 4x and 3y. 4x and 3y. 4x and 3y. And in terms of the powers, I'm going to start this one off at 3 and then reduce it by 1 each time. So this is 3, 2, 1, 0. And these are going to get built up here. So this is going to be 0, 1, 2, and 3. So the first thing we're going to do, and I'm making that worse by trying to write over it to clear it up a little bit, is we're going to type this combination into the calculator. Now at the end of this problem, I will bring up a graphing calculator and show you what that would look like and how it would work, but at this moment I'm going to tell you what the value is, and then again at the end of this problem I will show you what this would be on the calculator. So the combination of having to choose 0 items from a group of 3 is 1. There's only one way to do that. Now here I'm going to go 4x quantity cubed. So that's 4 times 4 times 4, x times x times x. That's 64x cubed. And 3y to the 0 power is just 1. So 1 times 64x cubed times 1 is 64x cubed. There's the first term of my 4-term problem. Now 3 objects, if I choose one of them, there's only 3 ways to do that. Now 4 times x is 16x squared. And 3 times y to the first power is 3y. So now I'm going to go 3 times 16 times 3, which makes 144, x squared y. And you'll see the natural decline of powers in x and the ascension of powers in y. So if I'm choosing 2 items out of 3, in any order, there's 3 ways to do that. 4x to the first power is just 4x, 3y to the second power is 3y, or 9y squared. So this is going to be 3 times 4 times 9, which is 108xy squared. So you see the x's are decreasing in power, the y's are increasing, and again we will explain how 3 over 0 made 1, 3 over 1 made 3, 3 over 2 made 3, and finally 3 over 3 makes 1, because this is choosing 3 items from a group of 3, and there's really only a way to do that. You just grab it all. There's one way to do that. 4x to the 0 power is 1, 3y to the third power is 3 times 3 times 3, y times y, or a total of 27y cubed. So our final term is 1 times this, 27y cubed. Well, there it is, guys. There are the 4 terms I have in the problem here. Beautiful as they are, I still need to go back and show you where I got the 3 over 0, 3 over 1, and these combination formulas. So if you could quickly copy this down, or just, make sure to rewind the video, I want to show you using the graphing calculator how to do that. So here is a graphing calculator, and here is me typing in the example of the 3 over 0. You click on the 3, and then you choose Math and Probability, and then you choose option number 3, which is NCR, or the combination, and having 3 items and choosing 0 only gives you 1 possibility. By clicking second enter, I can kind of recall this equation and change this last number to a 1 to indicate what would be that, coefficient for that problem. Well, it's going to be a 3, and then multiplied by the other number, 16 and the other 3 from the y, would give me that total of 144. Then we hit second enter and change that back to a 2, so this would be the parenthesis of 3 over 2. And this gives me choosing 2 items from a group of 3, which is 3. And then finally, our last problem, which many of you can guess that if you have 3 items and you're choosing 3 at once, there's only one way to grab all of them at once. So there it is. That's the way that we are going to type in. Now again, I'm not going to show this for the rest of the video here, but this is how you would get those answers the quickest. Though there is another way to do it. If, for example, you had, 3 choose 2, the way you can write that is 3 factorial divided by 1 factorial times 2 factorial. So this is really the n factorial divided by n minus r factorial times r factorial, which is 3 times 2 times 1 divided by 1 times 2 times 1. 2 divided by 2 is 1 over 1. So this whole thing is 3 times 1 over 1, which is 3. So that's where you can see this 3 choose 2 just spits out a 3 right here. So again, I find it's faster on the calculator, but depending if you own one of these or not that can do that, or if you just want to write this out, I mean, it's your choice, but this is how you would process those mama owls in the problem. Alright, so now we're going to put our graphing calculator away for the rest of the video, and we're going to scroll down and do the second of 4 examples here. Now this one's going to have 5 terms because its power is 4. So we're going to start off with 5 blanks. Whoops. 1, there we go, 2, 3, 4, and 5. And start with the mama owls with 4, and then increase the bottom number by 1 each time until it matches the, whoops, I almost made that look like a fraction, until it matches the number on top. So that's the mama owls. The baby owls will be a 3x and a negative y for each of these. 3x and negative y. 3x and negative y. Oops, looks a little sloppy there. 3x and negative y. And one last one, 3x and negative y. And I prefer starting with the 4 and dropping this by 1 power each time, and I do like putting the 0 there, so we get the symmetry as this grows from 0 all the way up to 4. And some might complain that, this is just a little time consuming, but I do like the symmetry of 4, 0, and how they all match. Like this is 4 minus 0 is 4, 4 minus 1 is 3, 4 minus 2 is 2, and this ending power is always the bottom number of these combinations. So this combination is going to give me 1. 3x to the 4th power is 81x to the 4th power, and negative y to the 0 is 1. So our first term is 81x to the 4th power. Now this choosing 1 from the 4 is going to be 4. 3 times x to the 3rd power is 27x to the 3rd power, and negative y to the 1st power is negative y. So multiplying the 4 times 27 times negative 1 is negative 108. And then x cubed y is the variables involved. Then for choosing 2 here, this is going to give us 6, and then 3x quantity squared is 9x squared, and negative y times negative y is positive y squared. So this is 6 times 9, which is 54, x squared, y squared. Alright, so for choosing 3, so if I'm choosing 3 items, I'm going to have 4 as a possibility there. That's from doing the combination formula. 3x to the 1st power is just 3x, and negative y to the 3rd power is negative y, negative y, negative y, which is negative y cubed. So this will give me a subtraction of 12x y cubed. And again, before we get to the finish, you can see my x's are decreasing in power from left to right, and the y's are increasing in power from left to right. And now we have finally hit 4 over 4, which is going to be 1. Because there's only one way to grab 4 items from 4 items. You just yank, grab them all. 3x to the 0 power is 1, and negative y to the 4th power is a positive y to the 4th power, which is our final term, plus y to the 4th. And this is my 5-term expansion of that binomial. So for our final 2 problems, you'll see me actually kind of like not go that far, because if you don't read the instructions, you're going to be in a world of hurt because you're going to be listing at all 16 terms. But in fact, I'm going to actually just do kind of like take a lead from the book here and just say, hey, there are 3 terms. If you can do 3, you can probably do 4. And if you can do 4, you can probably do 5. And as the slippery slope goes, you can probably do all of them. But I'm just going to make you do the first 3. So we're going to put down 3 blanks. And then the ... because this will go on. And then we're going to then do the mama owl. But then the mama owl's only going to actually go, 2 more than the start. So a total of 3. Which means that your babies, you'll only need 3 babies. Here's your x and 3. Here's your x and 3. And here's your x and 3. All right, so we're going to start this off with the power of 15. Wow, and the power of 14 and 13. Boy, I'm sure glad that x didn't have a coefficient on it, or else that would make it really big because it's to the 15th power. And we're going to start this off with 3 to the 0 power, 3 to the 1, 3 to the 2. So this 15 choosing 0 is 1, and then we have x to the 15th, and then 3 to the 0, that happens to be 1 as well. So my first of the 3 terms is x to the 15th. Now here, my 15 choosing 1, that is going to be just 15. And then this is x to the 4th, 3 to the 1st power is 3. So this is going to give me 45 x to the 14th power. Whoops, I forgot my 1 there. 14th. There we go. Now here's where I really appreciate having a calculator, because this is 15, excuse me, 15 choosing 2. Now if I type that 15 choosing 2 on the calculator, I get an answer of 105. 105, that's pretty amazing. Now again, if you didn't have a calculator, 15 choosing 2 is another way of saying 15 factorial divided by 2 factorial, and then the subtraction of these 2 in front, which is going to be n minus r, or 13 factorial. And the way to kind of break that down is 15 times 14 times 13 factorial. I'm going to stop right there, and then I will go down here and write 13 factorial times 2 times 1. These simplify, and then what makes this important is that we are going to excuse me, we are going to then divide this by 2 and this by 2, so this is 7. So 15 times 7 is that 105, and then it's divided by 1, so there it is. And again, I could do this on the calculator, it's really quick, but this is the way to do it by hand, and this would give me x to the 13th power times 9, because that's 3 to the 2nd power. So my third term here is 945 x to the 13th power, and so on and so forth, because I feel you could probably do more than 3, but I'm not going to make you do all 16 terms that would be involved in this problem like this. So you're welcome, I guess. So now let's do these 3 terms here, 1, 2, and 3, and start off with 10 over 0, and then 10 choosing 1 and 10 choosing 2, and then we'll have the mama bear, or sorry, the little baby owl y, but y is going to start off with the power of 10 and reduce by 1 each time, and we're going to start off with the negative 2 to the 0, negative 2 to the 1, and then negative 2 to the 2. So 10 choosing 0 is 1, y to the 10th is just y to the 10th, and negative 2 to the 0 is just 1. So this is y to the 10th. That is the first term. Then we're going to go 10 choosing 1 is 10, y to the 9th, and then this is going to be multiplied by negative 2. So our second term is a negative 20, y to the 9th. And for my final term here, since we're not going to do anything past the third term, we're going to go 10 choose 2, So this is going to mean that we're choosing 2 from 10, and that answer is 45. Again, I can quickly type that in, or I could go 10 factorial divided by 8 factorial times 2 factorial. And if you want to see that written out, this would be 10 times 9 times 8 factorial divided by 8 factorial times 2 times 1. So those simplify. This makes a 5. 5 times 9 is 45. Times, y to the 8th, and then negative 2 to the 2nd power, which is 4. 4 times 45 is 180 times y to the 8th power plus dot, dot, dot. It just goes on and on. But you have clearly shown, if you can replicate this without the video here, you clearly showed to me you understand the binomial expansion. And I appreciate you sticking through these 4 videos, which now clocks in almost at 50 minutes here. So I do appreciate your time and effort watching these. And thanks again. I really appreciate it.